In this video, we're beginning to introduce triangles. Previously, we learned about points, we learned about lines, then we moved on to parallel lines, as well as the angles created by parallel lines. So from this point forward, several chapters about triangles. So first of all, we need to know how to classify triangles. We classify them either by angles or by sides. And let's see. This part is all review. The first triangle you see here, obviously, this is an acute triangle because I've got three acute angles, right? But if one of the angles is an obtuse, and then we just call it the obtuse triangle, and same is true with right angle. This is a right triangle. And finally, if I have three angles that are all congruent, we call it equiangular. I cannot say this word. Equiangular triangle. Okay. Here's some practices. If you look at, I like to draw them out. So if you look at this diagram below, we have to classify these angles. CDE, where's D? CDE is here. So obviously because of this, that is a right triangle. If I change to a different color, BCE is right here, and because angle C here is an obtuse, so that's a obtuse triangle. I should write triangle down. And ABE is right where this blue is, and because of these tick marks, that is a equiangular triangle. Okay, and if I want to erase the rest of it and then go back to BDE, BDE is because of the obtuse angle there, which is right here. If I use the black mark, that is an obtuse triangle. And finally, CFE is the smaller one, so that is an acute triangle. Okay, fairly straightforward. Now let's look at how we classify them by sides. If I have three congruent sides, I have an equilateral triangle. And if it's only two sides, I have a isosceles triangle. And none of the three sides is congruent. It's called scalene triangle. I have a tendency to call it scalene triangle because my children love scalene pancakes. So that's how we classify them by sides: equilateral, isosceles, and scalene. And the example below, triangle JKM. JKM is a scalene triangle, and KLN is a isosceles. So you're basically looking for the little tick marks that gives you information. Finally, JKN, that's obviously a equilateral triangle. Okay. I'm gonna do a couple of examples below, but you should finish the entire practice. So I'm gonna do number 9. Number 9, obviously, I have a right triangle here, and I have two tick marks here that indicates that they're isosceles. So that's what I'm gonna write, right? And isosceles. So right triangle is classified by angle. Isosceles triangle is when I classify them by sides. Same thing here for number 10. I have and obtuse, if I classify them by angle. Since I have no tick marks, even though the two sides, the shorter two sides look congruent, but if I have no tick marks, I cannot make the assumption that they're congruent. Therefore, this is a scalene triangle. Okay. Third one, number 11, I have all three sides being the same, and I have all angles being congruent. So obviously, this is a equilateral and equiangular. All right, so finish the bottom three. The answer key is on the website. Make sure you check it out. I'm going to demonstrate how we do this one. I'll do a couple of them and leave others to you. So this is telling me PR bisects SRT. So SRT is here. PR is right here. That's PR. So what that's telling me when they say bisects, what that tells me, let me make a different color. When I say bisect, what that tells me is that this angle and this angle are congruent there. So SRQ is congruent with QRT. U is the midpoint. So if U is the midpoint of RT, RT is here, which means this part, UR, this part and this part are congruent as well. Okay, so then we have to classify the angles. So let's see how we can do that. UQR, that triangle, I have UR and QU being congruent because of the tick marks. So they are isosceles. And because I also have angle RUQ being 120, so this is an obtuse and it's isosceles. Triangle RST. RST is this big one. Let's see. If I have, looks to me, I have this angle being 60. This angle, I don't know. However, because I have SRQ being 30, and QRT must be 30 because of PR is the angle bisector. So in fact, all three angles are congruent. Therefore, my conclusion there is this is an equiangular. Oops, sorry. Equiangular triangle. Okay? And also, if it's equiangular, must be equilateral. Equilateral. And let's see if that's the case. If I look at the sides, I have 16 here. I have 8 and 8. 8 plus 8 is 16. I have 8 here. But notice, remember this part, the UT and UR are congruent. So this part, even though there's no markings there, this must be 8 as well. So if this is 8 meters, the RT adds up to 16. So all three sides are congruent as well. Okay, so let's see. I can't erase the dots. Oh well, now I messed it up. So we just proved that RST is equilateral as well as equiangular. Those are probably the most challenging. Give the rest a try and see how what you can get out of it, and then bring your questions back to the classroom. Finally, let's see. Classifying triangles in the coordinate plane. So now I don't give you a diagram. I don't give you the measurements of the sides or the angle measures. I give you some random coordinates, so then I ask you, what is it that we can do? So if you recall the distance formula, which is y2 minus y1 squared plus x2 minus x1 squared, right? So if you're given 3 points in this example here, J, K, L, and you can use that distance formula to calculate the 3 sides. So let's do that. Let's see if I calculate the distance of JK. Y2 minus y1, so I would have negative, I have 1 minus 7 squared plus negative 9 minus 7 squared. So if you put it in your calculators, that should come out to be square root of 68. You can take the square roots if you want, but you can just leave it in the square root for comparison purposes. And if we do the same thing with KL, I would have minus 1 minus 1 minus 1 minus 1 squared, that's just parentheses, plus minus 1 minus negative 9, whole thing squared, and that should come out to be square root of 68. Oh, this looks promising. And then not JK anymore, we already did JK. What's the third one? So we have JK, we have KL, so the third one should be JL. And JL, so if I do minus 7 minus 1, whole thing squared, plus minus 7 minus 1, whole thing squared. And this one is not 68, it's 72. So that means that out of these 3 sides, 2 sides are congruent, and that kind of triangle, obviously, the only kind that meets that criteria is an isosceles, right? So if it's helpful for the first or 2 questions, you can take a graphing paper and graph it out if it's easy. But if not, just imagine, you can just just think about any kind of triangle, and you can just have 3 points, and the coordinates are given. The coordinates in this case, it's not right. I'm just saying if this is negative 7, negative 7, negative 9, 1, negative 1, negative 1, and then you're simply measuring, using this distance formula, measuring each side, measuring each side and knowing how long they are, and then comparing their length. So this is the process. It's a little bit tedious, but you get the concept. Okay, so I am not going to demonstrate all of it. You should finish the rest of it, the rest of the page. And you know what, let's do number 20 you should finish number 22 and then finish number 24 on this page. So finally, we can also add a little bit of algebra in this as well. So let's see how we do this. If ABC is an equilateral triangle, solve for both x and the y. So we know if it's equilateral, all 3 sides are congruent. And probably the easiest thing is just to, because this only has a number there, this length there, so then we set it up. That's the setup. And so I should have 3x equals 48 and x equals 16. That's my x. And I can do the same thing for y, because they are equilateral, and I should have y equals 5 if you do your solve for your algebra. Let's look at number 4. Number 4 says if DEF is an isosceles triangle with DE, DE is here being congruent with EF. I have to find X and find the measure of each side. I would highly recommend that you circle out what you're being asked for, because a lot of students just stop here and don't measure the sides. So the key word here is isosceles. So that tells me the relationship of the two sides. They're congruent. And if you do your algebra, you should have x equals 10. That's not 6, that's a 0. X equals 10. Once I find x, I can plug in to find my DE. And that's 8 times 10 minus 13 is that 67. If I have DE, I have EF, should be 67 as well, but please do double check. And for DF, I have to plug it in. I should have 31 here. So those are your final answers of the length of each sides. Okay. On the last page, those are exactly the same type of problems, but notice that they don't give you a diagram, which is really challenging sometimes. So I highly recommend that you spend more time in finding out what the diagram is. So let's take a look at this. If PQR is a equilateral triangle, I'm given the length of each side in the form of an equation. I have to find the x and the measure. So I don't know what it is, let's just randomly. It's equilateral, so sorry about that. I am terrible at drawing. Equilateral, so all three sides are congruent. And if this is PQ is here, QR is here. PQ is 18x plus 1. QR is 24x minus 17. PR is 15x plus 10. This is much easier, okay? Then now you can set it up. So solve for x. Any sides would do. 18x plus 1 should equal 15x plus 10. And you should have x equals 3. And your length should be 55. So work it out yourself. I'm only setting it up for you. So, it looks like a lot, but they're all fairly similar, and these are great practices. The best thing is I would take a step back and look at how we sort of organize the materials. We're classifying triangles, but from there we can go for the angles or we can go for the sides. And these specific keywords like equilateral, equiangular gives you an equation in there, and you want to highlight those keywords and draw your diagram so that you can solve for the variables and find the length and the angles of the triangle. Okay, guys, I will see you in class. Bye.